Assalamualaikum and hi everyone. So today I will present about YouTube trending with trees and cues for data structure project. So I would like to introduce my teammates. So my name is Shazwani Balkis binti Saiful Bahrain.
My name is Mufti Umaira binti Saifuddin.
My name is Sharifah Umiara Kisina binti Said Muhammad Faiza.
And my name is Putri Nobalkis binti Muhammad Zulkifli.
So I would like to present about introduction first. So YouTube has become a popular and engaging platform for student learning. So it's offer like a free video and simplified explanation, making a complex topic easier to understand for student. And data structure like stack, queues, tree, graph, linked list, and array list are commonly taught. And YouTube videos often use a real life example to explain on how these structure work. And for instance, the YouTube video queue helps illustrate the FIFO, which is first in and first out concept of queue. And this method connects the theoretical concept to the real world platform, enhancing the understanding. And students move beyond the memorization and start applying concept practically.
So I will explain about how the application works. So first of all, for the user profile, user have unique profiles that will be stored in a database allowing for quick lookups. And second, for video metadata, information like title, description, text, and thumbnails are stored in structured format. And as for the search algorithm, YouTube search engine uses indexing and ranking mechanism to retrieve videos efficiently. And for the recommendation on system, um, it will analyze it will analyze the user behavior and preference to suggest video using the AI based models. And for the comment system, comments are stored in hierarchical formats, allowing replies and threads. And as for likes and dislikes, dislikes are tracked using a simple counter or associative mapping per video. And subscription stores your user subscription to channel for easy retrieval. Streaming protocol uses adaptive streaming with buffering techniques to optimize playback. And lastly, for the advertisement, ads are placed based on the bidding and relevance using an automated ad serving mechanism.
So stack usage in YouTube. So first of all is a watch history. So each video watch is pushed back into the stack. As we know that pressing back pops to the top video to go to the previous one. So for the second one is undo and redo action. So action like adding and removing video are pushed into an undo the stack, and also undoing an action push in push it onto a redo stack. And app navigation, which is a mobile app, each screen or view, which is like a home video comments, is pushed onto a navigation stack, and pressing back pops the top screen to return to the previous one. So browse history when you use a via web. So basically, like browser often use a stack based approach to track and visited pages similar to the YouTube Watch session. And for the last one is video suggestion preview, which is edge case. Temporarily previewing a suggestion video can use a stack to return you to the original video context. And for the next one, I will be explaining about benefits of stack. So the first one is last in and last out, as we know is LIFO. So allow access to the most recent item added, ideal for undo operations, and efficient memory management, which is efficient memory management. So simplify the function calls, which is support the recursion by maintaining a function call history via the call stack. And easy to implement. So simple and straightforward data structure with a basic push or pop operation. And backtracking support, which is a useful in algorithm like maze solving or parsing an expression. And I will pass to the next one.
So now I will present about how YouTube use data structures in its watch queue features. YouTube allows a user to line up videos to play one after another one. This is called the watch queue. And it follows the queue data structures, which works in first in and first out or FIFO system. That means the first video you add will be the first to play and new videos go to the end of the list. It's simple but effective way to manage playback orders. Next. Let's look how the queue works step by step. Imagine if I add 3 videos to the queue, video A, video B, and video C. First video A plays. When it ends, YouTube automatically plays video B, then comes video C. This shows how the FIFO behavior clearly. The video at the front always play first and the new video are added to the back. Using a queue brings a lot of benefits to this system. It keeps the videos to in exact order how you add them. It's super easy to keep adding more videos. The next video plays automatically, no need to keep clicking. It gives a smooth and relaxing watching experience, and everything stay organized, even if you add a lot of videos. This helps YouTube give users a better and more hand-free experience. So the next I will present about linked list in YouTube. The YouTube watch queue also behave like a linked list, and linked list allows a user to be added at the end and removed from the front, which is perfect for how YouTube's watch queue works. You can also reorder, skip, and remove videos easily because each item is connected to the next one like a chain. Here are the benefits of using linked list. It's easy to update. You can add or remove videos anytime. The size is flexible. There's no limit to how many videos you can add. You can skip or move videos around. The order of videos is always maintained, and it's perfect for features like watch later and or up next. That's why a linked list is a great choice for managing videos queues that change often.
So I will continue about the array list in YouTube. So array list is a dynamic array used to store and manage lists of items, and it's usually used for watch history, recently watched video, list of video in queue watch list, and search result. For example, you can see on the photo stated here, the YouTube may use an array list to store recent search. It is either because it's index-based and dynamically resizable and keeps insertion order, which perfect for a user's sequential search input. It's typically the user can see it on the search bar and the previous search that they search on the YouTube. And the benefits of using array list: first, it's maintained insertion order, which the element stays in order to in the order they were added, which is useful for maintaining user history or sequence. Second, allows duplicates, useful when storing repeated items like recently watched videos or repeated search queries. Third, integrated with collection framework, can be easily sorted, searched, and manipulated using built-in Java utilities. And last but not least, better performance than linked list for access. Access time is faster and compared to linked list. And next is tree in YouTube. YouTube uses a tree structure to organize its videos, starting from a main category like music, gaming, and education. Each of these can have more specific section. For example, music, they might have pop or rock, while gaming could include mobile or PC games. This structure helps YouTube keep content well organized and make it easier for users to browse or find videos on their interests. So benefits of using a tree in YouTube: first of all, it improves content discoverability, supports better navigations, efficient data classification, enhance user experience, and enable personalized filtering.
So I will explain about use graph in YouTube. Graph help user with track to interact with the video, find pattern in viewing behavior, recommending video to user. So as you can see in the picture, what is happening here is user A, let's say user A watched video A, and user B watched the same video, which is video A. But at the same time, user B also watched video B. So YouTube will recommend video B to user A. So the benefit of using this graph, first is track user video interaction efficiently. This helps to monitor which user watch videos to do meaningful connection. Next is Google's viewing pattern and similarities, identifies user with similar interests based on share watch history. Next is improved recommendation accuracy, suggest videos by analyzing connection between users and their watch content. Next is support collaborative filtering, recommends video watched by similar users that the user hasn't seen yet. And last but not least, it scales well for large dataset. Graph can manage millions of users and video with fast lookup and relationship. So next is implementation on stack. So as you can see here, the code is actually simulate video list for queue. Next code, this is to handle add in queue. Let's say a user want to add video in their queue. Next is handle remove from queue for user to remove a video from the watch queue. Next code is function to get video details by ID. The next code is to check if the video already existed in the queue so that the video won't duplicate in the watch queue. So last but not least is display the list of video that user has added to their queue.
Okay, so for the running time and efficiency estimate of the algorithm, so as the first one, I would say like it's adding a video to queue in array and a video ID, $ session and also queue. So time complexity is ON, where N is the number of the item in the queue, and linear scan through the queue to check if the ID already existed, and session queue equal to video ID, and the time complexity O1 appending to the end of an array. So the second one is removing a video from queue. So basically, we have like array underscore filter, and time complexity is ON. It's loop through the array and create a new one without the matching ID. So which means that it will not repeatedly going to loop. So display the queue. So for each integrates over the queue, it's ON. So get video by ID, and the video and video underscore ID, linear search through the videos, OM, where M is the total number of the available video, and here M equal to 5. And the last one is, so total for the all queue item is ONXM. So I pass the next one.
So for the next one, I'll talk about the conclude in the findings in 3.1. The YouTube video queue simulation in PHP is a session-based web application that allows users to view a list of predefined videos, add selected videos to a personal queue, and remove them as desired. It uses basic PHP data structures like index and associative arrays along with session handling to store the user's queue without a database. This means like instead of using a PHP or database, it will like use a session to remember each the user's queue instead. And the operations such as adding, removing, and searching videos are performed using linear time complexity (ON), making it efficient for small data sets. And the interface is simple and user-friendly, providing visual feedback on queued items. And overall, it's well-structured prototype suitable for learning, session management, and basic dynamic list handling in PHP.
And for the next one is output. So as we can see, we have the available video. For example, we have the learn PHP in 10 minutes and top 10 CSS tricks. And we have the button like beside on the right side, which is add to queue. So which means that whenever you click on the blue button, it will immediately put in the playlist to queue. So which means that whenever you click, so it will continuously add it to queue. And then your queue will display on the your queue, which means that at the place where no video in queue, but if you click, then it will put on the your queue. And the next one is the code explanation. So session start, which means that the session start and uses the session start to enable the session-based storage for user video queue. So static video list define an array of video, each with a unique ID and title. And queue initializing the check if the queue is already in the session. If not, then initialize it as an empty array. And add to queue, check if the add parameter is present in the URL, and add the video ID to the session queue only if it's not already in it, so which means that it will not repeatedly put on the same one. And remove from queue, which is check if the remove parameter is present, uses array underscore filter to remove the specified video ID from the session queue. And video lookup function, get video by ID, finds a video details from the list using a linear search. And front end, which is HTML, displays available video with add to queue or in queue indicator, and show the current queue with the option to remove the video. And styling, basic CSS for layout, spacing, and visual cues for interaction.
So now let's look at how this is done in a code. In real programming, YouTube can use collection classes like linked list or array list to build queues. These classes come from the Java collection framework. For example, the queues interface provides methods to add and remove items in order. The iterator interface is used to go through the queue and display the videos. These tools make it easier to make the list behind the scenes. Here's some common operation to use to control the watch queues and the function. And queue to add the video to the end of the queue or one time. And dequeue remove the first video or end if using array. P show the next video without removing it. For each loop, use to display all videos in the queue. Empty to check the queue if it's empty. This operation help make the system run smoothly and efficiently.
Okay, so for the conclusion for this project, the first is the project demonstrates practical use of arrays to stimulate a video queue. Second, associative arrays are used to store and process video metadata, ID and title. PHP sessions serve as a temporary persistent storage mechanism for maintaining user-specific queues. Next is array operation, like in array and array filter, efficiently manage add and remove functionality. Next is a custom search function, get video by ID. Retrieve video details by ID, stimulating lookup in real-world application. And next is enhance data integrity by avoiding duplicates and providing safe HTML rendering using HTML special chars. Overall, the simulation results follow the file structural principles like list management, element uniqueness, retrieval, and state persistence.
And that is all from us, and thank you so much.